In this video, we want to evaluate this particular integral here two ways. You want to give this a try? Go ahead and pause the video. I'll be right back. So the integrand in this one is a rational expression, and it's not in simplified form. The degree of the numerator is larger than the degree of the denominator. So I'm going to do, first method I'm going to use here is I'm going to go ahead and simplify this. Use long division, divide the numerator by the denominator. So x into x squared will give me x, then multiply the partial quotient times the divisor. This will give me an x squared here, plus a 3x. And we subtract here. X squared subtract x squared gives me 0, and then 0 subtract 3x is a minus 3x. The degree of the divisor is 1. The degree of the remainder is 1, so I can continue the division. So repeat this, x into minus 3x is a minus 3, and minus 3 times x is minus 3x. Minus 3 times 3 is minus 9, and then here we subtract. We get minus 3x, subtract minus 3x cancels, goes to 0, and then 0 subtract the minus 9 is a plus 9. So we stop, and we get a remainder of 9. So I can rewrite the integrand here as the quotient, which is x minus 3, plus the remainder, which is 9, over the divisor. So this is just another way to express the integrand. And then we can integrate here term by term. Antiderivative of the integral of x with respect to x is x squared over 2. Add 1 to the exponent and divide. Get x squared over 2. Integral of minus 3 with respect to x is minus 3x. And this one, you can think of this as 9 times 1 over x plus 3 dx. So the integral of 1 over x plus 3 dx is the natural log of x plus 3, absolute x plus 3. Put the 9 on front. Now you could use a U-substitution, but you don't need it. The derivative of x plus 3, if you let u equal to x plus 3, the derivative of that is dx. So du would be dx, natural log of absolute x plus 3, plus your constant of integration. So this is what you get if we do it that way. Now a second way you can do this, and you might find a third way. If you do, you can put it on the comments, the description. That's your answer there. Another way we can do it is use your standard U substitution and say let u equal to x plus 3. Then du would equal to derivative of x plus 3 would be dx. Derivative of 3 is 0, so this will just be dx here. And then we need to transform everything in terms of u. So obviously x plus 3 will be u, and then we have an x, but we need it in terms of u, so let's do it this way. If we solve this right here for x, take the 3 over, u minus 3 is equal to x. So now we can do this. Integral of, and x squared can be replaced by, square both sides here, u minus 3 squared. X plus 3, that's u, and dx is du. So then we expand the binomial in the numerator, minus 6u plus 9. And that's over u. Then we divide through by u. So u squared over u is u, minus 6u over u is 9 over u. And then we integrate term by term with respect to u. So for integral of u, add 1 to the exponent, that would be u squared, divide by the value, get that, minus 6, integral of that with respect to u is minus 6u. And the integral of 9 over u, again, that's your standard formula for natural log here, 1 over u. So this would be 9 natural log of absolute u plus your constant of integration. All we have to do now is just replace the u by x plus 3. So it'll be u squared here, so this is x plus 3 quantity squared over 2 minus 6 times u, and u is x plus 3. And it's plus 9 natural log of the absolute value of u, and u is x plus 3. And then it's plus the constant of integration. And then we do the algebra here. X plus 3's quantity squared. That'll give me x squared plus 6x plus 9 over 2. And then on the next one, multiply by minus 6 here. Gives a minus 6x minus 18 plus 9 down to the absolute value for natural log of absolute x plus 3 plus the constant of integration. X plus 3 here. Now it's just a matter of simplifying this again, so we can take this out of here. Go over here then. Got x squared over 2, and then 6x divided by 2 is 3x plus 9 over 2 minus 6x minus 18 plus 9 natural log of absolute x plus 3. But let's see what we have here. We have x squared over 2 as part of the answer. That's what we got using the other method. And then here we have a 3x and a minus 6x. That's a minus 3x. We got that term using the other method. Of course, here we have the constant of integration. Then we had a plus 9 natural log of absolute x plus 3. We got that using the other method. The only extra stuff that we have here is the 9/2 minus the 18. So this is what we got using the other method. And then we have the additional values of 9/2 minus 18. But keep in mind that 9/2 minus 18 is just a constant, another constant. So I started off with a constant here. I'll just say add, and I'll just put another constant. I'll call it C1. So in other words, I'm saying this 9/2 minus 18 is a constant, and that can be absorbed with this constant right here. In other words, you can disregard them. You couldn't disregard them if they had a variable, an x or an x squared. But if they're just numbers, you can say, okay, these constants will go with this one here. And this is the answer. X squared over 2 minus 3x plus 9 natural log of absolute x plus 3. And that's going to happen when you work an integral problem like this using, say, two different methods. It's possible that you come up with the exact same answer. Sometimes you'll have the difference in the two answers will be a constant, like it is here. But we can say it's absorbed in this one. So rather than computing this out, we just say, okay, that's constant, and we'll leave it as part of this one here. Thanks for watching. We'll see you next time.